Hi, my name is Edgar and I'm happy to present our work on semantic image synthesis. Semantic image synthesis is the task of translating a label map into a realistic image. So far, impressive results have been achieved, overwhelmingly with methods that are based on generative adversarial networks, known as GANs. These methods suffer from two specific problems, which we solve in our work. The first problem of current methods is the reliance on the perceptual loss. So what is the perceptual loss? This loss extracts deep features from real and fake images with a classification network that was pre-trained on ImageNet. The distance between these deep features is minimized to bring fake data closer to the real data. The default choice in semantic image synthesis is the VGG network. The perceptual loss improves image quality by a great extent and is crucial for semantic image synthesis. However, it also comes with downsides. First, in our work, we show that the perceptual loss biases the texture and color distribution of images. Secondly, we show in our work that the perceptual loss greatly reduces diversity of the generated images. This brings us to the second major problem of the current method. The second major problem is low diversity. This means it is hard to sample many different looking images from a single label map. We solve these two problems with our two main contributions. First, we devise a new GAN discriminator architecture that eliminates the need for extra supervision from the perceptual loss. Second, we devise a novel noise injection scheme that allows for the first time to sample diverse multimodal outputs directly from input noise. In effect, we achieve a new state-of-the-art for semantic image synthesis. We name our model OASIS, as it only needs adversarial supervision for semantic image synthesis. Our method is based on the previous state-of-the-art model SPADE. SPADE uses multiple discriminators at different resolutions, as well as the VGG perceptual loss to achieve satisfying image quality. In contrast, OASIS replaces these losses with a single discriminator that is made of the same network blocks as a SPADE discriminator. However, it has an encoder-decoder structure. This allows the discriminator to learn on the fly to segment images into n real semantic classes or one fake class. Hence, it has n+1 output channels. The generator and discriminator play an adversarial segmentation game. The generator tries to fool the discriminator to predict real semantic classes, while the discriminator learns to predict real semantic classes for real images and the fake class for fake images. Please note how the label map is used. While previous methods concatenate the label map to the discriminator input, OASIS uses the label map more efficiently by using it as a target for the loss. The effect of the new discriminator is a strong performance gain, with or without the VGG perceptual loss. Our second contribution is a 3D noise injection scheme. At every training iteration, we perform the following steps. First, we sample a 3D noise tensor and concatenate it with the label map. Second, this composite tensor is used as input to the first generator layer, but also as input to all intermediate layers. To be more precise, the 3D tensor is the input to every spatially adaptive normalization layer. In effect, the model does not ignore the noise because the noise modulates directly the activations at every layer of the generator. At test time, we can sample noise and generate diverse images for every label map. However, we can also sample different noise for different image regions. This allows us to change objects locally without changing the background. It also allows us to resample arbitrary image regions. Lastly, we can perform meaningful interpolations in the latent space of the generator. The main result of our modifications is a new state-of-the-art for semantic image synthesis. On average, we achieve an improvement of 5 FID points and 7 MIOU points with adversarial supervision alone. The FID score measures image quality, while the MIOU measures the alignment with the ground truth label map. The improved alignment with the label maps is a consequence of using the label maps directly as targets. For an in-depth quantitative analysis of the components of our model, we refer to our paper. In conclusion, we present OASIS, a new state-of-the-art method for semantic image synthesis that uses adversarial supervision alone. The key components are a novel discriminator that makes the perceptual loss superfluous, and a new 3D noise injection scheme that greatly increases the diversity of multimodal image generation, but also allows local editing of images. Here, to round off the video, we show more examples of images generated with our method. These images are not generated via cutting and pasting. Instead, these images are synthesized by the generator in one single forward pass. This works because the generator is spatially sensitive to noise that is sampled independently per region. For more details and additional information, please have a look at our paper.